Okay, and we're live. Welcome everybody. I love doing these webinars because it kind of makes me feel like I'm fulfilling my childhood dream of becoming a YouTuber. So my YouTube channel. No, I'm joking. So a very warm welcome to everyone. This webinar is on the battle of the aquatic plant invaders, where we're going to just chat about where they come from, why they're bad for us, and the aquatic ecosystem, and how do we get rid of them. So I'm Julia Evans. I'm a climate and biodiversity journalist at Daily Maverick. And today we're joined by Dr. Julie Coetzee, who is a principal scientist at the South African Institute for Aquatic Biodiversity. And she's also the deputy director of the Center for Biological Control at Rhodes University. And then, of course, we're also joined by Dr. Ferrial Adam, who is an environmental justice activist and the executive manager of WaterCAN, which is an initiative of Outer. And a very, very warm welcome to everyone in the audience. Please remember that the chat is open and this is a discussion between all of us. So please ask any questions while we have these experts on our panel today, because I promise you these ladies are the best in the business because I'm always bothering them for questions whenever I write about this. So yeah, I think the first thing that we should probably discuss is water hyacinth, because I think that is the first thing that comes to mind, water hyacinth and water lettuce, when we're thinking about invasive alien aquatic species. So Julie, where is water hyacinth from? Because obviously it's an invasive species. And how long has it been in South Africa for?
Water hyacinth. Hi, Julia. First of all, thanks so much for having me. I'm pretty excited to be a part of this. And yes, water hyacinth is obviously not from the African continent. It's from South America. Its origins are the Amazon basin. And along with a lot of the other aquatic invasives that we have in South Africa, it's this group of floating aquatic plants that evolved in the slow-moving Amazonian waters and are now have been introduced around the world. And the estimate is that they arrived in South Africa sort of towards the end of the 1800s, early 1900s. And our first record is from the Cape Flats in Cape Town in the early 1900s, and then on the Vaal River in 1910.
Yeah. Okay. Also, sorry, I feel like I should have did this at the beginning, but obviously we're speaking about alien and invasive plants, so those are not indigenous to South Africa. And any invasive plant, whether it's in your garden or in the water, is not great because it wasn't meant to come from the space it's in, because it will affect like the natural biology and things, just like as a really terrible layman's explanation.
I think it's
So
understandable.
yes, okay. And then Ferrial. Oh wait, actually no, let's also talk about water lettuce. Where is water lettuce from? And how long has it been in South Africa?
Similar to water hyacinth, also comes from the Amazon basin, although there is some evidence that it was on the African continent during ancient Egyptian times. Apparently, there was a hieroglyphic or something of water lettuce. But then with past, with global climate changes, and I'm not talking about current climate change, but past freezing events and heating events, it obviously became extinct on the African continent, and subsequently has been reintroduced more recently, again in the early 1900s.
Yeah. Okay, cool. And I see that there's some questions coming in already, so that's great. Keep on sending them. Before we get to those, I just want to ask Ferrial, what causes the expansion of aquatic alien invasives? So if you've ever driven past Hartbeespoort Dam or the Vaal River a few months ago, you would have seen what looks like a green mat that you could walk over, but you would sink. But I mean, it looks it's so thick you can't even see the bottom. So what causes this sometimes incredibly rapid expansion of
So I think
these species?
so. Good afternoon to everyone, and thank you for having me on this panel. I think the first one is covered by Julie in that it's intentional releases. So for whatever reason, people think that it could be used in their garden, or lettuce looks nice in their pond and it cleans their local pond. So then they get them and then it accidentally gets released into a broader system. But what we have is that because of the high nutrients in our water, it kind of just speeds up the reproduction of these plants. So, for example, like just in simple terms, we've got a lot of sewage and agricultural fertilizers and pesticides that's going into our rivers, which is not being, our wastewater treatment works are not working really well. So it goes straight into the rivers, and that nutrient then creates that cycle of eutrophication, which is an excess of nitrates and phosphates, and that is like, it's like growing food for these plants. So they basically just explode.
Yeah. And when you say nutrients, it's a bad type of nutrients in this case. Yeah. Okay, we're definitely going to discuss more why this is bad for people and for the water. So I think that's actually what we should talk about now. Why is this an issue? I mean, these are just plants. How can they be that bad? Ferrial, do you want to talk about it?
Sure. I think the first thing is that the fact that they're alien, that they're not indigenous to the environment, means that there's an impact on the environment itself. And what you would then have is biodiversity loss. So it could impact other species, it could overtake other natural species, whether it's bugs or whether it's plants, and it affects it like that. So it's the biodiversity impact, and that's why it's a problem. The issue that for me is also very important is the quantity of water and the quality of water. So what it does is it reduces water flow in terms of quantity, because like you said, it creates these big, it looks almost like golf courts or like grasslands, but it's not, it's the dam, right? So it affects the quantity because it increases evaporation, it reduces flow, and because you have these mats on the top, it increases siltation in the dams. Siltation is the accumulation of sediment. And then in terms of quality, you've got it elevates the nutrients that we're talking about, the nutrient concentrations. It reduces oxygen, which then affects the fish. And all life within that environment. So that's the biodiversity lost. And then there's an ecosystem function that it affects directly. It's the water that it affects. So it's the water flow, and it can impact, if you have heavy rains and you don't have proper flow of your rivers, you're going to have floods, etc., that then becomes a byproduct of having these species in your water. And then, of course, there is an economic impact. Because if we look at what's been happening around Hartbeespoort, around the Vaal, it is affecting tourism. It is affecting some of the, the kind of boating and those kind of things that people want to do. And then health. So an increase in the nutrients can affect people's skin, also in terms of drinking water. And if our wastewater treatment works are not doing well in cleaning it, you're just making it harder. By the way, just to add to that, why I'm saying drinking is because almost 9% of South Africans, maybe 10% now, rely on open water for their drinking water supply. So rivers, dams, wetlands. And if it's got high levels of nutrients and bacteria in it, then they shouldn't be drinking it. It could cause illness.
Yeah, that's super, super important. Julie, is there anything you want to add about the problem of this?
No, I think Ferrial's covered it.
Okay.
I think where we sometimes lose sight is the biodiversity impacts. Those usually are pushed to the back because of the economic and the social and the economic impacts, which are obviously really important for human livelihoods, especially in further north in Africa, where people rely on access to water for their survival. But, if we're looking at ecosystem services that freshwater ecosystems provide us, it's the reduction or the change in community structure and biodiversity that these invasive weeds result in that takes away the benefits of these water bodies to the world, to us as humans, to animals relying on it, to water supply, all those issues.
Yeah. No, it is super interesting. Like, I feel like initially a lot of communities obviously freak out because of the tourism impact. Well, in my experience, because I wrote a lot about the impact of water lettuce and hyacinth on the Vaal River, but then, you know, pun intended, when you look under the surface, it's actually so much worse.
So much worse.
So what are the ways that we can deal with this problem? So I think, like, as I said, I was writing about the impact on the Vaal River community earlier this year, and it was pretty amazing how a lot of people in that community rallied together to try sort this issue out. And the first thing they did was just physical removal, trying to pull those plants out. But what are the ways we can deal with this problem? And I think we all secretly or not secretly know, based on the title of this webinar, what the maybe best solution is. But Julie, do you want to just take us through what are the ways we can deal with it?
Yeah, sure. I mean, you've alluded to what the community on the Vaal River did, which was nothing short of spectacular. So we've got physical removal. Usually we say that it's not a long-term solution because it requires frequent removal. So if you're going to be putting people in or harvesters in, and people who live around Benoni Lakes, around some of the systems in the Western Cape, and there's a lot of systems where these big harvesters have been bought or donated or what have you, and they look good for a bit, but the plants just outgrow any removal, particularly in the warmer summer months. On small systems, sure. There's a system in Boksburg, where Whitfield Lake, where they did manage to remove the plants, but it's usually temporary because these plants have huge seed banks. The seeds remain dormant while there's a full cover of plant over the surface, and as soon as that plant is removed and it warms up, then we get germination and we get new plants forming and covering the surface. So any kind of physical removal is continuous. It's expensive. Yeah. It's dangerous in terms of risks, from drowning to crocodiles or hippos, depending on where you are. Obviously, there's chemical control. So in South Africa, glyphosate is registered for use, and that's a very controversial topic, and I don't think we should delve too deep into it. It is very effective. It's very expensive. Again, it's short term. You have to keep applying herbicides if that's the route that you're going to go. And again, the plants will germinate from any seeds. And then there's the impact of glyphosate on aquatic life, although there's studies have shown that these plants, that the chemicals do dissociate in water and become inactive. I'm not going into that. And then there's what we do, which is biological control. So releasing insects that are specific to these species for the control of the plants. They can only feed on these plants. But what we realized is we've changed our approach to an inundative approach, where, similar to constant removal using physical removal or chemicals, we constantly apply these insects to get a faster knockdown. But again, it's sustainable, it's cheap, and there's no negative impact on the environment. And then an integrated approach using a combination of these methods is usually what would give us the best outcomes.
Yeah, I'm so excited to discuss more about the biological control. The first time I heard about it was from an invasives expert that isn't Julie, and then I found Julie because of all the work she's done, and I found it so interesting and so cool. But we have so many questions coming in from the chat, so I just wanted to ask some of them. So, and I think it's something that's on a lot of people's minds. So Catherine asked, is there anything that you can do with the removal of water hyacinth or water lettuce? Like, can you use it for compost or something? And I think, like, a general question some people have when they hear the story is there any economic benefit you can use from the plants? Maybe Ferrial, you could touch on that.
Yeah, I mean, I think that there have been examples of people using it in terms of, firstly, in some places for bioenergy. So you can use it as a fuel. And yes, for composting and fertilizer, and in some places also for animal feed. I think Julie would be better placed to answer how much of that we're doing here. I think that is the challenge in terms of getting it done here.
Yeah. Actually, sorry, Catherine also asked that she's interested to know what happens to water hyacinth once it's been removed. So I'm also interested to know that. Julie, what do we do with well, I suppose when you're physically, or she's referring to when the water hyacinth would be physically removed. But then obviously we know with biological control, the water hyacinth would die and sink to the bottom. But yeah, do you want to comment on the economic benefit of it, or if it makes for good compost?
Yeah, absolutely. I think the fact that there's so much of these plants on systems that you think, well, we have to be able to do something with it. And yes, you can, as Ferrial said, you can make compost. There are biogas options, phytoremediation, so cleaning the water from heavy metals or chemicals are all things that these plants can do. And it's water hyacinth, water lettuce, kariba weed, they're all excellent at taking up what's in the water. And so we think, well, yes, we definitely should use these things. As invasion biologists, as biocontrol scientists, we don't ever promote the use of these plants because you don't want to create a demand for something that is these are the world's worst weeds. So if somebody starts making a viable industry out of compost from water hyacinth on one system, who's to say someone will have a look at this and think, oh, well, I'm going to do this on another dam where there isn't any water hyacinth. So promoting this, so the economic use has the potential to spread the plant so that people can make money off it. It is any use of an invasive species has to be permitted by Department of Forestry, Fishery and Environmental Affairs. Any transport of an invasive species has to be permitted. So there are a lot of legal requirements for using this. There's obviously cottage industries that pop up if you've got an invasion on your property and you remove it and then use it within your property, that's fine. But remember, these plants have seeds that remain viable. They reproduce vegetatively, and so you could risk the spread you could risk spreading the propagules unknowingly. And I guess it's a bit of a wicked problem because surely we should be using it, but at the same time, the environment, the negative impact. So it becomes a bit of a cost-benefit issue. And I think our government's taken the stance of not allowing the use unless you've specifically been given permission through some kind of tender process or application to the department to use it in a secondary industry.
Yeah, it's interesting. I'm looking through the questions and quite a few people have asked about it in different ways. Like Richard Holder from Four Ways said he's interested in investigating the ability of using these invasive plants to extract biopolymers from them. I might have messed that up. And also Irina Luck was asking if you can produce biofuel and also composting. But like you said, well, these are obviously invasives and they have seeds and they're not meant to be here, I think is the bottom line, right? But I understand with the biofuel argument, like we do need to look at alternatives. Yeah. But so like
may I add to that?
You're basically not allowed to, is what you're saying, unless you get permission.
But the other thing is that these plants, there's a lot of them, but they're 90% water. So your return on investment is really, really poor. So you have to move something that weighs, say, 10 kilograms. Only 1 kilogram of that becomes viable material. So again, it's because they're so high in water content, they're also very high in silicate, so becoming fodder becomes an issue. And then the other issue is, what about all the pollutants that they're actually taking out of the water? And now, so they bioaccumulate heavy metals, they bioaccumulate toxins, and now to use that, particularly, I guess, in some kind of fertilizer or compost issue, you're distributing those chemicals further. And
Yeah.
I have no idea. Sorry, Richard from Fourways. I have no idea about biopolymers.
Yeah. No, yeah, it's an interesting one. I guess I know there is some work with terrestrial invasives that I think WWF is doing on using those for biofuel. But that's so different because terrestrial invasives and water invasives. But yeah, it's a good question. And another question, which I think is a good way to segue into what actually is biological control. So Peter Knox asked, insects have no negative consequences on the environment, but the hyacinth sinks, rots, and then eutrophication is exacerbated, or am I missing something? So I think this is a good point to explain exactly what biological control is and how it works and the pros and cons of it. So like I said, Julie is the Deputy Director of the Center for Biological Control. So Julie, can you give a explanation of how this process works? I know you explained briefly what it is, but just what you would do. And we can use the example of maybe the weevils, because that's been like in the news a bit. And then Ferrial, you can chat to the pros and cons.
Sure. Yeah, so as we said, species become invasive because they're introduced to a new place where they didn't, in the absence of their natural enemies. And their natural enemies are herbivores or diseases. And the herbivores we're talking about are small insects or mites. And the diseases are usually things like fungal pathogens or bacteria. And so as biocontrol scientists, we go to the center of origin, we find the plant in its native habitat, and we look for these herbivores that are feeding on them. And insects have got a very specific, the majority of insects have a very specific relationship with their host plant. So that means every plant in the world has got at least one insect that only feeds on that plant. And that's what we term host specific. So they can only feed on and complete their development on that plant. And we look for those, bring them into South Africa. We're not the only country that does this. The US is very active, Australia, New Zealand. We're trying to get Europe to accept the practice. And we bring these insects into our country into very strict quarantine conditions where we test their specificity. So we test them against closely related species. We test them against indigenous native species. We test them against economic crop plants to ensure that they meet this requirement of specificity. Once we're satisfied that they are specific, we apply to government, so we apply to agriculture and we apply to environmental affairs for permission to release them. This goes through a scientific committee and then we get approval or not. Then we can start rearing the insects and releasing them. To talk about what happens to the plant biomass, that it increases eutrophication, we must remember that we're dealing with highly polluted systems. So something like Hartbeespoort Dam it's probably one of the most polluted systems in Africa. The amount of nutrients coming into the system, what water hyacinth takes up is 0.1% we've found of the phosphates that come into the system. And they're not introducing new nutrients. They're merely using what's already in the system. So when the biocontrol agents feed on them and they die, they're sinking to the bottom. And yes, they're going to release nutrients, but they're releasing the nutrients that they took up from that system already. In addition, we're slowing down the growth of these plants, which would die naturally and add that to the water anyway. So it's not a net gain of nutrients in the system. It's a stable cycling, I guess, of the nutrients.
Yeah. So, for example, with the weevils, you release the weevils, and I saw them for the first time when we were at the Vaal River, and they're so tiny. So you release them onto the plants, and they eat the plants, and they make little holes, like, for example, with water lettuce on the leaves. And so they don't eat the whole plant, they just make little holes, and then that kills it and it sinks to the bottom. And that's the way of eradicating it, just in super simple terms, right?
Essentially, yeah. So that feeding damage actually results in waterlogging. So those tissues are normally waterproof. Now suddenly you introduce little holes, the little larvae tunnel, and the plants get waterlogged. And that heaviness and losing that waterproofness is what results in them sinking.
Yeah, that's really interesting. I thought when I first heard about it that they had to eat the whole plant, but this seems less effort and better.
Yeah, way less.
Yeah, and then also what's so great about it for people is that you release them and then they do the work for you. But we'll get onto what you can do if you're part of a community and want to get involved just now. But I think the question a lot of people ask is how long does this take? Julie, I think, to answer.
Yeah. We are impatient people. We are after instant gratification. We want solutions now. We live in a world of bigger, better, faster, more. Biocontrol is a long-term process. The important thing is to know that biocontrol doesn't eradicate invasive species. It brings them down to, well, our aim is to bring that population of invasion down to an acceptable level of control. And that can be decided by government. It can be decided by the people on the water body. So if we say we're happy to accept 5% of the plant being there, that's the best outcome for us as biocontrollers. So we have to accept that these plants are always going to remain in the system. We've changed our approach to biocontrol in that in the past we would, develop these agents, apply for permission, rear them and release them, and then let them figure out the environment. So get used to the local temperatures, get used to the seasons. You must remember these insects come from the Amazon, which is tropical, and they don't really die back because of cold. Now we're introducing them into South Africa where we get very cold winters, we get a lot of frost, the plants die, the insect populations die, but then the plants come back. And it takes a lot longer for the insect populations to build up than it takes for the plants to explode. And this is often what we see in springtime. So our approach now is to inundate these plants, as I said earlier. So almost apply these insects as I don't want to say as a herbicide, but we broadcast apply the insects to get this faster knockdown. We've been working on Hartbeespoort Dam since 2019. We get complete control of the system by the end or by middle summer every single year. We have nothing over winter, and then they come back in springtime because the insect populations have died down over winter and because of the seeds. So we say in the tropics, biocontrol classically takes 3 to 5 years. We are aiming in our temperate and subtropical South Africa to reduce that time to try and get complete biocontrol within 2 years at certain sites. But it's all climate dependent. It depends on the amount of nutrients in the water and what have you.
Yeah.
Julia, can I add something?
Yes, of course. Yeah.
Yeah, I mean, I think one of the things is before we even get to biocontrol, which I think is a longer term management process, and that's something that, Julie has stressed, because yes, people do want the quick fixes, but we also need early detection. So we need to be able to not wait for things to explode before there's any action. So we don't have to wait for the whole of Hartbeespoort Dam to be covered before we realize, oh my word, there's a problem. So that's something we need to have in terms of environmental issues across the board. There has to be early detection and monitoring of our water systems. And without that, because then that's when you kind of say, well, biocontrol doesn't work, biomonitoring doesn't work. Well, yes, because you've allowed it to grow out of control. So you're dealing with an issue, for example, Hartbeespoort, that's like 15 years of growth now, and you want to solve it in 3 months. No, it's not going to happen.
Yeah, no, that's such a good point. But just to hone down, so it's like strangely controversial. Not strangely, it just, when you're speaking about biodiversity, I find it kind of cool and interesting how people get so passionate about it versus sometimes people are more passionate about this than when I write about politics, which I find interesting. But why is this approach favored by, environmental justice activists like yourself or water experts and scientists? Like what are the pros of this if it takes so long, Ferrial?
So that's the thing, is that it has to be consistent. And that is why I love the project that Julie's doing, because it's over a period of time, and it can show that over a number of years there's a change in behavior. So that's the first thing. The second thing is that, and people would say no, but when we sprayed, because we sprayed over the valve because of the water letters, they had to spray, and there was glyphosate, but no, it wasn't a glyphosate that was harmful or damaging to the water or to the environment. Now, I always get a bit suspicious, and that's me, because there are elements of glyphosate that are banned across the world, but we still use it very much in South Africa. There's a lot of our agriculture that has it, and we're not testing our waters to see how much of it is in our water and in our food. So I think that is why I'm saying is that when we look at, and I agree with Julie, that's a whole nother debate, because I think there's lots of angry people who propose spraying. But I think that's why I would rather prefer the biocontrol one. So for me, we need to be consistent. We need to have an early warning system or early detection, and then this system works. So in terms of the advantages of biocontrol is minimal impact to the environment is the first thing. I just need to add that 60%, and I'm sure that has increased, of our river ecosystems are threatened. And they're threatened by human activities as well as such chemicals that we are putting into our waters, the industrial stuff, right? And so it reduces toxicity in our water. And I think we need to have some kind of study and research that actually looks at the amount of these chemicals in our waters and into some of our food, actually. The other reason that we happy with biocontrol is that even for the people who are working around it, so there's safety for the workers that are working with those chemicals. And it's, in the longer term, it's cost effective, because you're not doing a blast and you have to do the blast, or when I'm saying blast, but a spray, or like just really shove the chemicals out there and then wait for another year, and then it comes back and you have to spend millions again. It doesn't eradicate the problem. And we need to find a biocontrol that would, with time, eradicate or actually minimize the amount of growth. And that we can't always eradicate, but you know what I mean, is that the growth is so much that the chemical sprays is a very short-term, I think, solution to what we're experiencing.
And expensive.
Yeah.
Oh, yes.
Yeah.
And expensive.
I think something that everyone struggles with when it comes to invasive alien species, and terrestrial invasive experts will say the same, you can't ever fully eradicate invasives, is the sense I'm getting from the experts, which is such a problem. But in the chat, I'm hearing quite a few questions come up about that, which is so fair. So Mlungile asked, to what extent can biological control work if the propagules remain lower down the water profile? The plants seem to come and go almost every year. How can we tackle the propagules? And then Quibusfell asked, what are the remaining plants at Hartebeesport Dam? Sorry, why are the remaining plants at Hardy's not removed? Plants will now start multiplying at a staggering rate. So I guess there's just like a big question is why just down to 5% every winter, and then it grows again? Like, how is that a solution? Yeah,
it's a good, all very good questions. Water hyacinth flowers produce thousands of seeds, and these seeds sink to the sediment, and they can remain viable for up to 25 years. So if we think that water hyacinth has been on Hartebeesport since the 1960s, there's probably a very big seed bank. There are a couple of things. First of all, herbicide applications often result in big flowering events following the herbicide to any plants that weren't herbicided. So often we see that there's an increase in flowering. At the beginning of the season, we sometimes see a lot of flowering. But what's so amazing is that the biocontrol agents prevent the plants from flowering. So if there are no flowers, there are no seeds. And anyone who lives at Hartbeespoort Dam will tell you that they haven't seen huge purple mats of flowers for years now, and that's because these insects prevent flowering. So no new seeds are being put into the system. And what we are looking at is the seed bank, and that over time, we're gradually depleting this huge seed bank to get to a point where in springtime, we're not going to get these massive germination events because we're mopping up the seeds each season. So it becomes it's a long-term project. It's relies on the fact that no new seeds are being put into the system and that the biocontrol agents are getting on top of the on top of the new plants each year. So in time, we're hoping that we get rid of this whole seed bank. Well, not hoping, we know that we'll get rid of this huge seed bank.
Yeah, no, that makes sense. So there's so many questions, and we're definitely, don't worry, we're definitely going to get to the source of the problem of why the water is full of so many nutrients. We're going to get to that because everyone in the chat is right. This is just sort of treating the symptom. We need to treat the root cause. But before we get there, I really want to speak about the Biological Control Center at Rhodes because I think it's so incredible. Because people are asking like how these rearing stations work and everything. And when I learned about the center at Rhodes, I don't know, it was just amazing because the people employed there are often people who are like excluded from the workforce and things. So I just wanted to chat about that quickly because Rena like asked where and how are the insects propagated or farmed? Do you need tons of them for this purpose? And then someone also asked how much does it cost, Philip Ivy asked how much does it cost to develop a new biological control agent? Who is paying for this research and ensuring that South Africa's research capability is sustained? Someone also asked if the government is helping to pay for it. Sorry, there's so many questions. I couldn't see whose name it was, but yeah, I think really important questions. How is this all happening? And yeah, where does it start? So Julie, I think you can chat to that and then we'll get to the rest of it.
Thanks. So at the Centre for Biological Control, we've got a very big, we call it our mass rearing unit, the Sesonke Weinek mass rearing unit, where we have, where we employ a number of people living with disabilities. And they've become our workforce who are multiplying our insect workforce. So they rear the insects, they rear the plants. We've got big poly greenhouse tunnels. And this program reaches across South Africa and it reaches beyond into Zimbabwe, Zambia, Malawi, Mozambique. We're really trying to get these insects further and further north. And in fact, we've got some US colleagues with us at the moment, and we've just collected 10,000 of these insects for them to take to the US, where hopefully we can get megamelis working in the US as well. So this is for water hyacinth. Funding has been a bit of an issue. So Environmental Affairs has always funded biocontrol research and implementation in South Africa, starting in 1994, 95 with the Working for Water program. And at the Centre for Biocontrol, we've always been very lucky to receive excellent funding from Environmental Affairs up until 2021, 22. Different fiscal requirements, supply chain management, procurement issues have stopped the tender process, and so we no longer have any funding from government for this, and we really we're operating on the smell of an oil rag or the whiff of an oil rag at the moment. We haven't stopped the work that we're doing. We've got various bits of money coming in here and there that we're really trying to eke out. And so, yeah, this anybody wanting to fund what we do, you know where to get hold of us. But what we've realized is that we can't rear as many insects as the country needs. And so we started engaging with communities probably 5 years ago already, and we started setting up smaller rearing stations around systems that were invaded. We've started them in East London, on the Nahoon River. We've got them on in Bonnie Vale for the Breda River. City of Cape Town, we've collaborated with them, and then all around the Highveld, so Benoni Lakes, Bronkhorstspruit, Falkop, and obviously Hartbeespoort Dam is our flagship, where we've got 10 of these rearing stations that are managed by homeowners associations or estates, and we've given people the tools to take responsibility for these invasions on their doorstep. So instead of saying, what's government doing about it, people can take responsibility and start seeing results and being a part of the solution to these invasive weed problems. And it's really easy. Someone said, how much does it cost? Well, you really need a waterproof container and some fertilizer, or if you live in a polluted system, you can just use that water, grow the plant, we'll send you the insects, and off you go. But in reality, a nice little station costs about 30,000 Rand. That includes the cost of a tunnel and the cost of these big plastic containers that we use from they call the impact tubs. They come from the fruit packing industry. And very easy technology to, if we can call it technology, but essentially to farm these insects. We've now set up a whole lot of these on the Vaal River, where people will be rearing the water lettuce weevils and the water hyacinth hoppers, because water hyacinth is coming as well. So yeah, it's currently not funded by government, but there's a lot of money out there. There's a lot of people willing to invest in this and take responsibility.
Yeah, no, that's amazing. You kind of addressed it, but just to confirm, Christina asked if landowners can obtain weevils for release, which, yeah, they can. And if yes, are there any criteria that has to be met? So I guess, how can people get involved? Like, let's say I lived along the Vaal River, what should I do?
Yeah, we obviously facilitate the whole process. We do have to get permits from Environmental Affairs, because you can't, you have to have a permit to legally keep invasive species. They come along and they inspect the stations, and together with my team, with Dr. Colby English, who's my lady on the ground. She's just amazing at what she does. She gets to these people, to anyone who wants to rear. We've got easy rearing guides, and she shows the way to do it. Problem shooting, and troubleshooting, problem solving. And then I think the other amazing thing that she facilitates is these people around systems, so like Hearties, Vaal, is everyone gets onto a WhatsApp group and says, hey, I've run out of plants. Does anyone have plants for me? My hoppers are eating us out of house and home. And someone else will say, oh yeah, I've got really nice fresh plants, here you go. Or someone will say, I really need hoppers for this section. Someone will say, oh, we've got an explosion, off we go. So it becomes a community of practice where the benefits are enormous, as I say.
Yeah. Okay, well, that's incredible. And now I feel like the question that everyone is asking now is, okay, this is all great, but what about the source of the problem? If the nutrient levels are still high in the river, is this not just, kind of like a futile battle? So, Ferrial, let's chat about it. Just in really basic terms, our wastewater treatment works, which are obviously meant to treat the sewage, either are not built for the expanded population capacity, or they're not maintained, and then that water gets released back into rivers as they should be. The water goes from the toilet obviously into wastewater treatment works, should be treated, then it goes into rivers and dams. But if it's not properly treated, or if the plant is struggling and it, like, raw sewage leaks out, it goes into our rivers and dams like Hartbeespoort, Vaal River, those places. And this has been going on for like years and years, and this is what's causing it, along with other like agricultural runoff and things, right? This is the heart of the problem, right? So how can we deal with this?
So also with everything that you've mentioned, because it's been almost, 10 years of deterioration in essence or more, there is no quick fix. It has to be, and I like what Julie was talking about, getting communities involved in the monitoring, and it's the kind of citizen science activism that we talk about.
Yeah.
So on the one level, we are asking people to test the rivers wherever they are. And, we talk about Vaal, we talk about Hartbeespoort, but there's a lot of tributaries that lead up into those rivers. And it's not just wastewater treatment works, it's also overflowing manholes that are harder to kind of find the issues. There's the Yucks Cave, for example, recently I visited, and usually it's okay in that spot, but you could see that there was a problem, and it's possible that there was a manhole and not the wastewater treatment work. So I think that one of the things is getting people involved at a local level, in your community level, to monitor those kind of things. Whether it's a manhole in your street in the middle of the city or urban area, doesn't mean it's not going to impact on how things happen in the rivers, because those things are going down the stormwater drains, right? That's the first. And the second thing is that we've been calling for a ring fencing of finance for the maintenance of our infrastructure, both the massive bulk infrastructure as well as at local government level, because the truth is it is failing and we need to fix it. So that's the second thing that needs to be done. I think at a national level, there seems to be a fixing of the department, but we cannot divorce the local government aspects. And that's the challenge, because national government's fixing and saying, oh, we're doing all of these things, but the pollution and all of that, that's go to local government. No, it's not going to work. You saw the AG's report yesterday. Local governments are in a mess. And so you cannot just say, now fix your mess. It's not going to happen. So we need to have a more coordinated approach with government, national, province, local, civil society and business all coming together to actually work on finding solutions. Otherwise, it's not going to be solved. It's too vast to be solved.
Yeah. Yeah, and something I do love about South Africans is that we are quite engaged citizens, and just seeing how communities have come together to deal with this. For example, Vaal River, because I did that story, but I know across the country is incredible.
Yeah.
But yeah, Ferrial, I just want to say, can you just explain like how people can test water? Because I know WaterCAN provides little self-testing kits. So can you just explain, like, if I wanted to test the water, because right now I'm actually across the road from Dalebrook Tidal Pool, and I'm pretty sure that's really badly polluted. So if I was going to go test that, how would I go about that?
Okay, so just before I tell you about the testing kit, 2 seconds, is that I also think that municipalities need to up their game in terms of their monitoring. So if we look at what's happening at the City of Cape Town, it's not because it's the City of Cape Town where they can actually see leaks better and they can monitor their wastewater treatment works and how it's operating. We should be having that everywhere. It shouldn't be a Cape Town thing. It can be done in Joburg very easily. So we need to demand that Joburg Water and Rand Water get those kind of systems in place. And they'll say, no, they don't have money, but they have money to waste. So they do have money. They need to look at how they stop wasting. So on the testing kits itself, we have a testing kit, which is really to look at drinking water quality, but you can use it in rivers, streams, dams. We've also used them at the beaches because you remember when the municipality says it's safe to swim, and then we found that our kids were saying, actually, no, there's high levels of E. coli, and then subsequently lab tests were done. So our tests look at pH, alkalinity, hardness, chlorine levels, and then it looks at phosphates, and it looks at nitrates and nitrites. All of those kind of things to give you a holistic chemical kind of idea or picture of the water. And then we have a bacterial side, which looks at total coliform. And then another little plate that breaks it up from coliform and E. coli specific. So you can tell if there's some kind of waste from animals or human gut in those rivers and streams. And I've had this question where someone said to me, but we know our water's polluted, so why should we even bother? The truth is we need to monitor, because it goes in cycles, and you'll find stretches of river that are very good, that are clean, and that, you know, are usable. And it's only through monitoring that when there's a spillage, you can pick it up in an area which was previously clean. So I think the monitoring is really important, and to get people involved. And what helps with this is that people become more aware of their water, and even more aware of the water as it comes back into their homes. So the wastage stops, the awareness in communities grows, in schools. And we try to get our testing kits everywhere, to schools, you know, to organizations. But we've had people in their homes say, look, I'm not worried, I'm worried about my drinking water. And then we send them a kit. We're having a week of testing, 16th to the 20th of September. And we have kits for free. So people need to just send us a mail and we'll send you a testing kit or two. What we really would like is if, like while Julie's doing her work, for example, or other organizations or residents associations who want to test monthly, that's what we want. We want lots of data, and we want monthly testing. We want that to actually help with giving us a picture of what we're doing, and tap water, rivers, streams, etc.
Yeah, well, that makes sense. Like we need the data to hold local government or these water bodies accountable. And I think the events coordinator can drop a link for WaterCAN's website in the chat, so you guys can go check it out, which I think is really cool. Another question which I'm seeing pop up, which I've heard in the past, which is an interesting critique. So two people asked it, but Hans Richard asked, what is the point of fighting the hyacinth? Are they not acting as filters cleaning the water? If you remove the hyacinth, another invasive will just take over due to the availability of nutrients. And yeah, I've heard that question. I've seen that question asked in a sort of other similar way with someone else. So yeah, I mean, obviously, if you remove the water hyacinth, the water is still toxic. So Julie, could you explain that?
Cool. What we need to understand is that yes, water hyacinth can take these things out the water. As I said, they do take nutrients up, they do take chemicals out. But first of all, what's coming into the system is immense. And water hyacinth only takes up at Hartbeespoort Dam, for example, it takes up 0.1% of what's coming in. So no, water hyacinth is not cleaning Hartbeespoort Dam. The negative impact on biodiversity, so reducing dissolved oxygen in the water, reducing light, the impacts that has on biodiversity are far greater than any benefit of a fraction of nutrients being taken up. And if you leave water hyacinth there, people are not going to buy property. People can't put their boats there. Businesses are not going to be able to attract people to come to the system. So you kind of have to choose your bad. And yes, you are right. You remove water hyacinth, we're going to get cyanobacteria. Or as is the case at the moment, another invasive called Salvinia minima. So as Julia said, as Ferrial said, we're treating the symptom of a far bigger problem. If we cannot clean the water, we are going to keep getting these invaders. What's worse, a green soupy muck of blue-green algae water, or a water body covered in water hyacinth. So I think you have to look at the benefits of having a clear water body, what they mean to people in terms of financial, what they mean to biodiversity, and then put pressure on municipalities to clean up the water, clean up what is going into these systems. That's the best thing that anyone can do. If you're an engineer, go offer help, or if you've got pots of money, go offer to upgrade a water treatment works. But we are dealing with one thing after the next.
I agree. I think we have to see people being put in jail actually for water pollution, and that is when behavior will change at local government level, but also at corporate level. We know that there are many companies that are just dumping We've got construction companies that are dumping rubble into stormwater drains, which affects the whole system, right? So I think that we need to have better enforcement. We've got the laws, we need to have better enforcement.
Yeah. Yeah, I think what gets lost is the point of dealing with the invasives, or the point of biological control isn't that, okay, well then now we're done. Like, no one is taking away from the fact that we need to deal with the source of the problem. It is the primary root of this, but obviously fixing those systems will take years. And in the meantime, not only is it having an impact on our drinking water, on tourism and the economy, but also just on all of the organisms living underneath. Like, if you just think about it, the way Julie explained it to me once made a lot of sense. Like, water lettuce forms and water hyacinth, they form a mat, so then no sunlight can get through. And obviously you need sunlight for all of these natural processes. I'm really simplifying that, but I think that's just like a good way to remember things. I've seen, we are running short on time, but this is kind of an interesting question because I've seen it come back in the past as well. So someone asked if Dr. Anthony Turnton mentioned a while back about microcytons, the danger of them in these types of eutrophic systems, and they asked if the panel had any comments on that.
I can say a brief, briefly, water hyacinth, the presence of water hyacinth usually excludes blooms of blue-green algae, which produce these microcystins, which are toxic. They can become airborne in aerosols, and they give lung issues and stomach upset. They smell terrible. So a lot of people have said we'd rather have the water hyacinth than the blue-green algae on a system. So if you take water hyacinth away, we're just going to get blue-green algae. And that is the case. You do, where you see a reduction in water hyacinth, you do get an increase in blue-greens. And that's part of eutrophication. They're taking advantage of the nutrients that are in the system. So when water hyacinth is there, no light, no photosynthesis, no blue-green algae production. That's the biological explanation.
Yeah, but neither should
But
be
then-
there. Like, the water quality shouldn't be like that, but then, as we know, invasive species shouldn't be there. Yeah.
So, I mean, I think it's the same thing that Julie's been mentioning before about weighing up the good and the bad, right? And yes, cyanobacteria does affect health, but I also think it's also partly fixing the quality of our water and the flow of our water. And so you will have it, but at a smaller level. I think that the choking of the river ecosystem by alien aquatic plants is worse in the longer term.
Yeah.
And that is something we need to understand.
Yeah.
And
yeah.
if I can add one last thing about that is, we said biocontrol doesn't eradicate. What we found at Harderbeespoort in the last 5 years, there hasn't been a blue-green algae outbreak in the same way that we've had on other systems where water hyacinth has been chemically controlled. And water hyacinth produces a toxin, it's called an allelochemical, which actually reduces it essentially poisons competitors. So it keeps out the blue-green algae. So biocontrol, in fact, is reducing the percentage cover of water hyacinth, but it's not eradicating it. And so water hyacinth is still producing those allelochemicals, keeping the blue-greens at bay.
Yeah, yeah. Okay. So, no, but that's interesting because I've seen that criticism or concern come up. And I think it's really good that people are thinking about this, the knock-on effects. And yeah, like we're coming back to, obviously there's the source of the problem we need to deal with. And then to deal with the invasives, let's look at the most sustainable solution for people and for the planet. I think we only have a few minutes left. So is there any final remarks each of you would like to say? Maybe Ferrial, you can start. Something that you want people to understand, or a takeaway message, maybe.
Yeah, I mean, I think that we've been focusing on, you know, what's been going on in the dams, etc. But I think that our bigger water and river ecosystems in South Africa are really struggling, and it's for a range of reasons. And the reality is that because the issues are so big, we really need to remember that we cannot rely only on government to do it. That does not mean we must open the door for privatization. What I'm saying is that people need to get involved. We need to be monitoring and not say, oh, well, I'm not going to be reporting this because, well, nothing happens. No, things do happen, sometimes in a smaller scale. I want to urge people to get involved, become that river monitor, the citizen on the ground that's monitoring, that's asking these questions. This question's been amazing. And keep pushing organizations, keep pushing government, keep pushing people to do the right thing, because I think that there's too much at stake when we allow our water, our biodiversity, and our river ecosystems to die.
Yeah, no, I totally agree. And like just looking at the chat and the questions, there's so much energy from people that we must use it. And there are things you can do. You do have agency and power as citizens. I know sometimes it feels like we don't, but anyway, this is becoming a TED Talk now. So but it is really cool to see. Like I always just think it's really cool that people log onto a webinar in the middle of their day on a Wednesday to have an intellectual conversation. But Julie, any final thoughts?
I'll just echo what Ferrial says. Stop saying what's government going to do about it, and you start to do something about it. Start small. Start small. Certainly biocontrol is an easy way to start, but again, it's the symptom. And yeah, look into public-private opportunities.
Yeah. It's been such a pleasure and an honor to have you both on the panel. If you in the audience don't know the work that Julie and Ferrial do, definitely take a look, because they've both spent years and years and years fighting for environmental and water justice. And yeah, they both have their doctorates and they have a lot of experience behind them, and it's pretty cool to do this on Women's Month. And yeah, once again, thank you guys, everyone who tuned in on a Wednesday. I think it's really cool that everyone came and is so passionate and has so many questions. And like they both said, water is, I mean, it's obviously super important. Okay, that sounded dumb, obviously. You know what I mean, though. But thank you guys so much for joining, and I hope that everyone has a great rest of your day.
Thank you so much,
Julia.
Yeah, thanks, guys.
I'm also happy to answer emails if people have email questions.
Yeah, you can send us questions if you still have other unanswered questions, and I'll forward them to the experts if there's still questions. Thank you, everyone, so much for coming.
Thank
it
you,
was
Julia.
it was really good to chat. Bye,
Thank
guys.
you, Daily Maverick.
Bye.
Thanks, Daily Maverick.